Object-oriented programming is based on four pillars: abstraction, polymorphism, encapsulation, and inheritance. Abstraction is the representation of all the essential features of an object, which means its possible states and behaviors. For example, when creating a program to represent a real-world object, the program objects are modeled to mirror the behaviors and attributes of the real-life objects as much as possible. Encapsulation is the practice of including in an object everything it needs, such as data and processes that are hidden from other objects in the system. For example, a driver only presses a button or turns a key to start a car engine. The mechanisms that make the engine to start are hidden under the car's hood, but the driver only interacts with a simple interface. Thus, encapsulation means making something private, and therefore accessible only from within the methods of its own class. A less restrictive mode known as protected can be used to make a class member available to subclasses as well. We have already learnt about inheritance, which means that one class inherits the characteristics of another class as part of its definition. A subclass that uses inheritance has the same interface as its parent class. This implies that you cannot hide a method in a subclass if it was declared in the superclass. Polymorphism means having many forms. It can be described as the ability of a program to detect the real class of an object and call its implementation even when its real type is unknown in the current context. There are several types of relations between objects. They include dependency, association, aggregation, and composition. Dependency is present if a change to the definition of one class might result in modifications to another class. It usually occurs when you use concrete class names in your code. For example, a professor depends on course materials. Association is a relationship in which one object uses or interacts with another. For example, in the classroom, the professor communicates with students. Association can be seen as a specialized kind of dependency, where an object always has access to the objects with which it interacts, whereas simple dependency doesn't establish a permanent link between objects. When one object uses the services of another but does not own it, the objects have an association. Aggregation is a specialized type of association that represents one-to-many, many-to-many or whole-part relations between multiple objects, whereas a simple association describes relations between a pair of objects. If one object contains other objects as replaceable or removable parts, then the containing object aggregates the other objects. For example, a single college department contains many professors. Simply, aggregation implies containment, but containment doesn't imply aggregation. For instance, a classroom contains students, but it is not made up of students. Composition is a specific kind of aggregation, where one object is composed of one or more instances of the other. If one object contains another object as a fixed, non-removable part, then the containing object is composed of the other object. The difference between this relation and others is that the component can only exist as a part of the container. In design patterns, objects and classes are represented visually using a Unified Modeling Language diagram, or UML diagram. A UML diagram can be defined as a view of a formally defined model. Relationships between objects are represented in certain ways within the UML diagrams. Associations are shown using simple lines connecting two objects. Unless otherwise specified, UML associations are bidirectional and supports messaging in either direction. When it is clear that messages go in only one direction, an open arrowhead points to the receiving object. Dependency is shown with an open arrowhead and a dashed line. The numbers at each end of the relationship line denote the number of objects that participate in the relationship at each end. This is referred to as multiplicity of the role. Aggregation associations are shown with diamonds at the owner end of the relationship. Composition is shown either with filled-in aggregation diamonds or the physical containment of classes within the composite class. This brings Lesson 1 on the basics of object-oriented programming to a close. See you in the next lesson.